what it is right now. And check this out, y'all. I had to stop in on you, let you hear a little something real quick, right? Because it's been a lot of downloads. You know, I know a lot of our minds have been coming up and formulating all kind of stuff, man. Has to be, because I have come. A lot of things have been just whipping through, you know, constantly. You know what I mean? And I know how to write it down, and you do too. You know what I mean? So what I've advised for myself is that I'm gonna have to start snatching this camera up, man, and regardless of what's going on and where I'm at, recording it. And because the knowledge is powerful, you know. So anyway, I believe it's due to the energy that's hitting and affecting the planet at this time, or the plane of existence in this location. So nevertheless, right, now I'm just going to inform you of a lot of things I'm bringing up. But the only reason why I'm informing you of this, you know, letting you know, you know, giving you notice, is because this, what I'm coming across is basically studying frequency, energy, and electricity, all right? And those are the foundations, all right, that I'm utilizing, because it's on a higher or a lower dimension, but it has guidance for certainty, because it is the functionality of how things work, how ions move, how photosynthesis work. Those are the teachers. Those are the master teachers. Not a tiff or a tilt, something like that. It meant not a period or a comma will be taken from the law. Okay? Nothing will be changed from these laws, and these laws are the laws you hear and see it all day, but don't recognize the dynamics in which the wisdom, the feminine energy, is given to you. Once again, this might turn out to be a long one, but we'll see. Nevertheless, it's much, so this is going to encapsulate a lot, all right? And someone who adheres to what I say and interested in some of these titles, make sure that you leave it in the comments that you'd like to hear about the thoughts I have regarding this, you know, these titles that I'm about to give you. But nevertheless, I don't know where to start, all right? But nevertheless, let's just go, okay, let's go to the superconductor, all right? All right, now I'm looking at how to make a semiconductor a superconductor. All right, we found out you have to be extremely hot or extremely cold in order for any metal to become a superconductor. All right, it must be extremely hot. All right, now when we talking about extremely hot, you might be talking about mechanics that go along with something towards a furnace and extreme heat and all this type of stuff, but not necessarily. Remember, we are naturally nature, so we'll look at the sun. We know that's hydrogen, and we know it's extremely hot. So how do we get it right before us, right? A magnifying glass, right? How do we melt the copper? Do we need a furnace? No. We need a magnifying glass, a bigger one. Not only a magnifying glass, right? But what we would need is, I'll show you. You go to the dollar store and you get them. It's magnifiers that you put up on a book. It costs $1. You put it on a book and it magnifies the words so ones with optical problems could read it sufficiently, all right? So we use that, all right? You buy the square, you buy a book frame, a picture frame that can access that 12 by 12 or whatever it is, 12 by 8 or whatever, 11.8 by 8 or some shit, whatever, all right? And you put it in that picture frame, take out the back and glue it in. Put it on a stand, like, you know, like the mirrors that they look in, the tall mirrors, put it on a stand like that and beam it down at what you're putting this certain degree up on, right? It'll be super hot. Now they say copper loses resistance when it gets super hot or super cold. Now I'm through the illustration of using liquid nitrogen, right, in order to make it a centigrade freezing level that causes the elements to lose all its resistance, right? They're therefore becoming a superconductor and conducting its own magnetic field even in the presence of other magnetic fields, right? So that's making it a superconductor. It can levitate, raise up, do whatever it wants, and all that type of stuff. All right, now understand this. Let me show you this real quick. Now it's gonna be a lot of these I'm gonna do like this, and this will be a little long. But let me get to the ones I was at another state. But I'm gonna show you this so I can do it in levels. I'm gonna show you this superconductor, and it's gonna end up on how they creating this weather. All right, so we're gonna see how long that's gonna be before I even change the subject. But this superconductor, I was looking in on it. Bear with me, y'all. Bear with me. It'd be worth it, for real, for real. Okay, here. It's called levitating superconductor on a Mobius strip. All right. Now, even the way this dude's talking, he's revealing a lot. All right. He's revealing so much, you know, genuinely. All right. Now, nevertheless, look, I'm gonna go through this a little bit, but what I'm gonna tell you is, he did it through liquid nitrogen. All right, and he put a piece of ceramic. All right, I talked about that earlier. I'll talk about it again, but just not now. But nevertheless, he used neodymium magnets. Now, normally we just put a magnet down. All right, no, we'll put the superconductor down, whether it be copper, but in this instance, it's going to be a piece of ceramic that's made from three different pieces of metal. Nevertheless, I'm trying to be more informative than I need to get straight to it. So let's get straight to it. So we put the semiconductor, which is a ceramic, down into some type of little styrofoam structure, and then we pour the liquid nitrogen in. All right. Then we take a neodymium magnet and we put it and situate it at the top of it, and it will stand and hold its place, and you can spin it, and it won't move out of the realm or out of the perimeter of the magnetic field. All right, now listen, he did and made a track, and he put this on it. With no further ado, listen.
Okay, there. So unfortunately, it warmed up quite quickly because obviously the effect only works
Hold on.
as long as it's at its superconducting temperature. So what's actually going on there? A good way to start to understand that is to think about how magnets interact with ordinary conductors like this copper tube.
Yes.
So if I just
I'm making a video.
This nut through, it falls all the way through very quickly, as you'd expect. If I drop a strong magnet through instead, it takes quite a long time. So the reason that's happening is as the magnet moves through the copper, it induces electric currents in the copper. Those electric currents themselves have their own magnetic field, and that magnetic field will always arrange itself so as to resist the motion that's creating it. This is the fundamental principle of electromagnetism, that moving magnets near conductors or moving conductors near magnets creates electric currents. Now, because this is not a superconductor, because it has electrical resistance, the currents that are created as the magnet falls through will always tend to die away. So if the magnet were, for instance, to be stopped by the electric currents, those currents would immediately die away and the magnet would start falling again. So what actually happens is it just falls slowly through the tube. If, however, this were a superconductor, those currents would not die away. As soon as you induce them by introducing the magnets into the tube, those currents would remain and would keep going even after the magnet has stopped. So if this were a superconductor, the magnets would basically be locked in the pipe. They would be effectively levitating in the pipe indefinitely. So that's part of the explanation. We're sort of halfway there. I'm going to get onto the track now. And to do that, we saw when I was demonstrating the superconductor on the track down here that the effect only lasted a few seconds. It warmed up too quickly. It warmed above its critical temperature and stopped levitating. The solution we decided on for the Christmas lectures last year was to make a little train/boat thing. So we've got a piece of the superconductor embedded in polystyrene with its own little reservoir for liquid nitrogen. So let's cool this down. Again, I'm going to, not a burger tray this time, a slightly different dish. Carefully pick it up, I think. So now I can send it around. come all the way back. Go back on top. This is why we made it like a Mobius strip, so it can go, so it comes back on the opposite side it went round.
Now you see that? Now I'm gonna stop it here real fast. All right. Now look, the reason why I'm gonna show you this. Now look at this. Now these are tracks made of magnets, and you see how easy it made it around there. Now we be talking about blood pumping, the heart pumping the blood. Then we found out that it wasn't the heart pumping the blood. It was the blood that flows through the heart that pumps the heart. Now, if the blood flowing through the heart makes the heart work, what moves the blood? I believe from this setup, not believe, but I'm coming to a conclusion which is not really totally concluded. But if you look at this, you can see that the cells in our body must be operating. Must be. Anything biologically, all right, or organically. I'm skeptical to use that word organic at this time frame and location. Nevertheless, our blood cells would have to be superconductive in order to move throughout the heart, make the heart pump, and get to its destination in fractions of a second. All right. Now we're going to keep on going though.
So if I just stop it there, so it's kind of locked into position. So it's not just repelling the magnets and hovering. I can sort of pick it up and then stick it underneath as well, and it'll hang there. So as I mentioned with the copper, when you induce electric currents in conductors with a moving magnetic field or changing magnetic flux, the electric currents that you create will always have their own magnetic field that resists that change, that resists that motion. So when it's hovering on top of here, gravity is trying to pull it towards the track, that small motion towards sets up electric currents in the superconductor, which have a magnetic field that resists that motion. But likewise, when it comes around and it's now on the other side, now gravity is trying to pull it away, so that act of trying to fall away from the track sets up a different set of currents with a different magnetic field, which this time are attracted to the track. So whichever way you try and move it, whether you're trying to move it off to the side, up and down towards the track, away from the track, the superconductor will resist that motion, effectively locking itself into position relative to the track, so that the only direction it can move is the direction in which the magnetic field doesn't change, i.e. along the track. So basically, the superconductor can be any kind of magnet it wants to be, or any kind of magnet it needs to be at that moment to keep itself in the right position relative to the track. So this material was a real breakthrough, and possibly the first step on the way to what might be the holy grail of superconductor research, which would be a superconductor that would operate at room temperature or close to room temperature, at which point we might be able to use them to replace all of the conventional conductors like copper and things that we use in all our electrical applications today.
All right, he said that would be good if we can get a superconductor that operates in its optimum, in its original position, but operating at room temperature. Now we know that melanin operates at room temperature, and it is a superconductor. Now remember that song that said it's power, wonder working power in the precious blood of the Lamb. Now I said some other stuff behind that. You know, it says, would you be whiter, much whiter than snow? There's power in the blood. Now that's funny. The superconductor is melanin operating at room temperature. It said, would you be whiter, much whiter than snow? Now, liquid nitrogen is whiter than snow. Matter of fact, it's dry ice, basically. It is snow. Let's listen to this again, wisdom. There's power. It says, I'm going to sing it a little bit like it. It says it's power, wonder-working power in the blood of the Lamb. Now the lamb, you already know, woolly hair, and it's a sheep though. It'll go for anything. And a sheep needs a shepherd. This is how you're getting played. All right, now that opened the door for that. Nevertheless, so here we go. There's power in the blood of the Lamb, There's wonder-working power in the precious blood of the Lamb. They didn't say the lion, but they said in the Lamb. All right, now check this out. They said, would you be whiter, much whiter than snow? There's power in the blood. There's power in the blood. Okay, enough of that song. But just that part right there lets us know, and we have been deemed to go against it. Would you be whiter than snow? Hell no. Why would you be white? White reflects energy. You know, it causes problems. Black absorbs the energy. White reflects more energy than a mirror. So no, I wouldn't be. But when you look at the term of superconductor, they're talking about the precious blood of the Lamb, which is the magnetics of the superconducting field that drives without being whiter than snow, without being a cold temperature, without being a 0 point, but operates its own magnetic field while at 0 point in room temperature. That's you, all right? That's every one of you, of us, all right? Now check this out. Now, like I said, these are hell of a downloads that I've been getting, but check it out though. Now, to make copper a superconductor, it will not become a superconductor here unless it's placed, right? The copper must be placed upon what? The copper must be placed upon something that can, melanin, that can operate at room temperature, right? See, when you put these on, if you're thinking in a certain mind frame, you won't get it. Nevertheless, yeah, see, this is what's called going out there, you know, and where there is only closing your eyes and I'm everywhere, you know, and you can go in there and get things out because you create it right there, but you have to have a starting point. The starting point is what it is, which is what you can respond and relate to and get a message, and it is direct from the cosmos and has been operating forever and ever, and not a word or a period or a comma will be taken away from it. The heavens and earth will crumble if you take something away from it. Now what did I tell you? Let's proceed. So nevertheless, the superconductor, right? Now, the superconductor is copper, but at room temperature, it is not. It must be frozen, flash freezed, all right? Now, if it cannot be flash freezed, then it must be heated up to a high temperature, all right? Very high. So what we do is we get that dollar refractor grade magnifier that reads from the book, put it down on the ground, and put a carbon cubicle or furnace thing and put some copper in there. Get a copper pipe, cut it up in small sections, drop it in there, and bring that flame to it, right? And you can boil it, all right? Now check this out. But boil it, right? Copper will burn up. So boiling the copper, you can make copper sheets, right? Out of a tin pan, an iron pan. But nevertheless, what you do with that copper is you keep building it until it gets thick. Super thick copper, the ones that they charge your ass so much money for. You want a big, thick piece of copper. Like that. You know what I mean? And then you can use your imagination and proceed. Nevertheless, okay, these are just snippets of these downloads, right? Now, let's go back to making a superconductor when it must be froze, because this is how I'm going to show you and explain to the knowledge that was given to me how they're controlling this weather. Now, when we look at this weather real quick, first of all, in the winter solstice, right, or the equinox, was it mixed up? Straighten that out, just that, right? You got it. We got it. So check it out. So nevertheless, the sun is more closer to the earth when it is wintertime. It is more closer. Let me see, I think I got these pictures. It is more closer to the earth. The sun is way more closer to the earth when it is wintertime. All right? And that is because of the way the earth is. At least that's what they're telling us, okay? Bear with me, bear with me. Um, um, uh, bear with me. I got so many pictures in here, snapshots. I'll be. Um, so the Earth is closer to the sun. And it shouldn't be winter. Why should it be winter at the time when the Earth is closest to the sun? You ever thought about that? And you say because of this, and it doesn't matter. If they're telling you that the sun is such and such big, and the Earth is such and such small, it doesn't matter what side it's on. If it's facing the sun, it should have sun. All right? It should have sun, period. It's nowhere around that. Don't believe something that you can't even see in your mind's eye. You know? Nevertheless, the sun is closest to the planet. I'm trying to let you see this so you can know. And you know it already. But I got so many pictures of different things that I have want to utilize. But I want to show you as I talk. I wanted to make a presentation, PowerPoint presentation, but I would not hold you any longer. Where is it? It might not be in this phone. Nevertheless, listen. Look it up. It'll tell you. It'll show you that the sun is closest to the Earth at this so-called time of winter. So why do we have winter if the sun is that close? All right. Think about it. Remember, we said if the sun moves an inch closer toward the Earth, it'd be hotter. If it was 1 inch farther back, it'd be colder. Remember that? So if the sun is revolving, and look, over here is summer. All right, it's summer. But over here it's winter. How? When it's this close to it, how do you get winter? How? What parts of your body is dead? Like the trees. They say the fingernail's bullshit. It grows. You say, well, so does the tree grow when it hibernates? What falls off? Dead skin. Goofy, don't get too confused. Listen to me. If the Earth is this close to the sun, it should not be winter. How are they doing that? All right, easily. I stumbled upon this simply because I was working with the superconductor. Now, the superconductor itself, in order to make it, it has to be cold, all right? It has to be brought down to 0 point. In order to do that, you need what's called liquid nitrogen, all right? Now check this out. I'm going to let you see this. I think it's from some university. And it's going to show you how to make the liquid nitrogen.
Here we are with Mr.
Hold on. It's going to show you how to make liquid nitrogen. Not really show you how to make it, but let me just go ahead because there's so many of these. I might be talking about the wrong composite of the wrong one. So let's go.
AP chemistry class, and we are experimenting with phase diagrams today, and we're going to try to make liquid carbon dioxide.
So, yeah, CO2. That's dry ice.
We're going to make it. So, TD, what are we doing here?
Putting the dry ice in the container.
We're putting dry ice in the container, and then what are we going to do? Anybody?
We're going to lower the temperature. We're going to lower the temperature and raise the pressure so we can go from CO2 solid to CO2 liquid.
We're going to lower the temperature?
No, raise the temperature. Raise the temperature.
We're going to try to raise the temperature a little bit, increase the pressure, and that's going to do what to the phase diagram?
Make it a liquid.
Let's get raise the pressure line up.
It's going to try to make it a liquid. Okay, so let's do this.
What is on?
It's the world's first.
Okay, doke, that should be good.
Maybe a little bit more.
Can't be
This is bad.
You can never have too much.
That's good, cap it up.
That's good.
There you go, cap it up.
Less is more. Less is more. It's going to be on him.
Initial operation.
High shoulder.
Get that technique.
All right, now just put it down here on the table, and I can, and we can see what's going on here. That's how easy it is. So what's going on?
It is increasing increasing in pressure and temperature, and it's going from a solid to a liquid.
The pressure's raising high enough to get past the triple point on the phase diagram.
Now, would you want to do this with a Gatorade bottle?
No.
That's dangerous.
It's called a bomb. That's pretty cool. Wipe the bottom of that.
That's what the last one of our AP chemistry class did.
Should we show them what it does when we take off the cap?
Watch this.
Okay. So now,
We're going to open it up.
set it down right there.
Take it from
And then
room
what do you do
temperature.
it? There we go.
Look at this fucking thing. Jesus.
God, that was awesome.
Boom.
Nice.
Whoa. Thank you, ladies and gentlemen. Straight back to the top.
Okay, now I'm going to stop there
Are
for
we
a
ever
minute.
going to have liquid carbon dioxide at our barometric pressure?
Absolutely not.
Heck no.
Never.
Stop being stupid.
All right, check this out, y'all. Okay, I'm making a video. Is it important?
Oh, okay.
Oh, okay, cool. Appreciate you. Now, check this out. I must hurry because I know I don't have that much time on this. But anyway, here it is. So, when we have CO2, this is how I found out is you can make something similar to liquid nitrogen, right? Liquid nitrogen is what you need, but they got it regulated so much. So my way, I was going to make some poor man's liquid nitrogen, and the way you make it is with dry ice and alcohol, 70% rubbing alcohol. You mix these two, and you have liquid nitrogen, poor man, all right? But the dry ice is very peculiar, all right? And so nevertheless, you just seen the dry ice stays cold, all right? Boom, it stays cold for a nice long time. You know, the people usually going camping and stuff. So nevertheless, he put that in a tube, forced it, you know, by closing it, forced it under the pressure, its own pressure, it became liquid. It became water, all right? It's through heating it up. It became water, rain. You understand? But soon as it got back to the pressure of the room temperature or whatever the environmental pressure was, poof, it turned into snow. Now I'm going to show you one more of these. All right, I'm going to show you one more of these. Just to, so you can get a, and CO2, once again, CO2 is dry ice. The little CO2 cartridges in the BB guns, the fire extinguishers that have CO2, you could take a pillowcase, put it over a fire extinguisher that have CO2 in it, and hit the fire extinguisher and let it blow the bag up. Keep it going like that and stop, open it up, and you can take dry ice out. Boom. And you have it right there. But it has to be a CO2 fire extinguisher. Now remember, they said it's CO2 emissions that's causing global warming shit. But think about that. You just seen the CO2 and how it works. It's dry ice. It's carbon dioxide, not monoxide. It's carbon dioxide, all right? So you just seen how its ability. Now these clouds look white, right? Some of them look heavy laden, like they got a time capsule in them or some shit. And when it hits a certain degree, it poof, turns into snow. Let's look at something again.
You don't have to hide.
Sure you do. But we see you. No, kick it.
Hey YouTube, I'm Nick from Nick282K, and this is liquid carbon dioxide.
Listen, I hope y'all can hear this. I'm gonna get closer.
Liquid carbon dioxide forms when the pressure and temperature inside a container approaches the triple point of carbon dioxide. This is about 5 atmospheres of pressure at minus 56 degrees Celsius. Here I've put some dry ice into a plastic bottle preform and put it in front of a 500-watt light to warm it up. As it warms up, the dry ice will sublime into a gas, which is carbon dioxide vapor, increasing the pressure. Once the pressure approaches 5 atmospheres, the carbon dioxide solid will start to melt and turn into carbon dioxide liquid. However, once all the dry ice has melted into liquid carbon dioxide, the pressure inside the container will rise very rapidly as its temperature approaches room temperature. Releasing the pressure causes the liquid dry ice to turn back into a solid, but this time instead of being heavy compressed dry ice pellets, it turns into a fluffy, kind of a foamed carbon dioxide snow. This foaming happens because some of the liquid carbon dioxide turns into a gas and is trying to expand out the end of the container, whereas the rest of it is cooled down by this expansion and freezes back into dry ice. After cycling one of these bottle preforms several times to get different shots, I noticed these small cracks developing on the inside. I suspect that the liquid carbon dioxide is starting to dissolve into the plastic, and when I let the pressure off very quickly, it comes out of the plastic, causing it to crack. I've marked this one and taken it out of service. I won't be using it again.
All right.
I hope you found this.
Well, yes, we did. So, nevertheless, this is what I found out by coming up with a superconductor. Now, that's all I'm gonna say right now for that part. You got enough. This is one of the bases of how to control that weather. All right. Now, let me see. Should I go forth? Let me see if I'm going to be missing a lot. But I'm doing. Matter of fact, let's keep it going. Let's keep it just going so I can make it a little bit more complete. All right. Now, what it is I'm gonna go to. I got it all spelled around here. You see. And the funny thing about it is, you gotta know it. Even scientists look up and they gotta know it. Even these people that made these videos gotta know it. Hell, they just told me. You know, a lot of things that we look past and be like, well, how is that done? And we actually be looking right at it, but have no ability to correlate things with one another, or have no ability to even think pseudo-ish. All right. I wanted to add one more, something about, let's see, CO2, because I wanted you to hear a little bit about what they talk about CO2 and this global warming real quick, so you can equate it. Well, forget it. Let me go here. CO2 and global warming exposed. Let's try that one. Okay, we just gonna pick any one. Let me see if I can get a good one, a short one. Explaining carbon dioxide and climate change. Okay, now what we just know from, and we found out from ourselves, let's see if it correlates with anything they finna say, or would they tell us something better. Let's see. We'll see it together. Okay, I'm not liking this one. I'm not liking that one. But nevertheless, and you got to understand too, we be seeing what they be spraying in them what's the names, and also the cloud making machines and things of this nature. But is it cloud making machines, or is it CO2 making machines? And then they tell us CO2 is messing it up. It's doing it. Yeah, you would know that, wouldn't you, if you're flooding the atmosphere with it, correct? No? I think so. And it's time that, I mean, ain't you just sick of shit? You know, we go through the same shit, you see this shit. And right now, everything, everyone knows every damn thing. For real. You know? I'm looking for one that works, that talks. Okay, let's hear this one. This sounds good. EPA administrator doubts CO2 is the leading cause of it. All right. Now this is for self-recognition. This ain't for going out for boycotting. We don't play no fucking games. We just pay attention, and that's all it is to it. This ain't to start no shit. This is to be aware of the shit. Not of Hershey's though, but that is good for us. Nevertheless, but not Hershey. The chocolate, cocoa.
of the Environmental Protection Agency. EPA Administrator Scott Pruitt told CNBC he doesn't believe carbon dioxide is the primary cause of global warming.
No, I think that measuring with precision human activity on the climate is something very challenging to do, and there's tremendous disagreement about the degree of impact. So no, I would not agree that it's a primary contributor to the global warming that we see. Or we don't know that yet.
Now let's bring in Carl Parker with some insight as to the scientific facts about carbon's relationship to the warming climate. Carl.
Chris, it is simply not true that there is disagreement amongst scientists, and there have been multiple studies that have shown that scientists agree, 97% of climate scientists agree that climate change is a man-made phenomenon. If you look at the rise in temperatures, you can see that they are concordant. They fit very well with the rise in CO2 that has occurred since the advent of the industrial age. Now, one could argue that perhaps that is just a coincidence. Well, let's take a look at another graph. This is showing us temperature reconstructions going back to the Ice Age from sediment and ice cores, and we see that coming out of the Ice Age there's a very gradual slope there, and so that is natural climate change. Takes place very, very slowly over thousands and thousands of years, and then at the very end of this we see a sharp jump right in there, and that is not natural. That is man-made climate change.
Okay. I'm gonna have to go back and check that for sure, because they just said some stuff, didn't they? Nevertheless, if you're dealing with superconductivity, if you're dealing with controlling the weather, if you're dealing with certain things that's happening on the planet, if you're dealing with making a dome, all right? Because think about it, when the CO2 hits the atmosphere, all right, when it's up in the air, it creates ice. It's ice. So instead of saying the ice is ice wall around the sides, like the flat earthers, what if the ice is, what if you in an igloo, and the igloo top is CO2, carbon dioxide? What if that's what blocks out the sun? What if that sheet can get thin or thicker? They spoke about the moon is fake or the moon is real, and they also have tales and stories that states that Enki and Elio or whatever, right? Or some beings brought the moon in here, and some people say it's natural. But check this out: Japan or China is about to launch their own moon in next year. They're going to launch their own moon to have more light in their cities at night. And check it out, it looks pretty damn big, and it's one-sided. It's almost like those umbrellas that you use in a studio where it holds a light and it beams it down, but it's actually inverted, right? It's actually inverted, and on this side it's just have standard poles holding it together out in space. You understand? They're launching their moon, a new moon for them. So what are we all speaking about? This is like natural intelligence heightened for better stimulation upon this plane of existence that we're on. Nevertheless, back to this climate change. I'm going to show you just a little bit of this real fast, all right? I hope it gets to the point where I want to talk about super quick, hopefully. It's been all around you. Just put them together, put it together.
Joining me now is Professor William Haffer
and this is only for
University. Good to have
educational
you with us,
purposes
Haffer.
with all this news popping
Thanks
up.
for having me. Good to see you. Whether global warming is real or not, the fact is it's a phenomenon that has entered the everyday lexicon. Everybody talks about it, and we're hearing it now again in the context of extreme weather. specifically this year's warm winter. I mean, I was talking to a friend just today who was from North Dakota who said even they had a warm winter. And President Obama, I think in a speech the other day, was remarking on the 75-degree winter temperatures and suggesting maybe this had something to do with global warming. Is there any relationship between this warm winter that everybody's talking about and the phenomenon known as global warming?
No, I don't think so, because if you look around the world, for example, it was an extremely cold winter in Alaska, in the Pacific Northwest, and in Europe, and most of Europe. So if you look at the global averages, very little has changed this year.
Right. And isn't the same thing said about the high incidence of tornadoes that we've been having, that this too is being driven by fluctuations in temperature, and everyone's acutely aware of tornadoes, the destruction they're doing, it strikes people as off the charts. I mean, is there any legitimacy to attributing that sort of phenomenon to?
Okay, you ain't talking about too much of nothing. All right, apologize on that one. Is like I said, there's so many. Okay, I'm looking for them to show you how it'll make this, it'll make ice dome. Stay with me, y'all. You're already using your head, what you coming up with.
To avoid dangerous climate change, we're going to need to cut emissions rapidly. That should be a pretty uncontentious statement, certainly with this audience. But here's something that's slightly more contentious. It's not going to be enough. We will munch our way through our remaining carbon budget for 1.5 degrees in a few short years, and the 2-degree budget in about 2 decades. We need to not only cut emissions extremely rapidly, we also need to take carbon dioxide out of the atmosphere. Thank you.
He says take it out.
I work assessing a whole range of these proposed techniques to see if they can work. We could use plants to take CO2 out and then store it in trees, in the soil, deep underground, or in the oceans. We
Now
could
check
build
that out.
large machines,
First of all, look,
artificial trees.
he just told you the truth. He said we need to take it out. By taking out the CO2, you allow the sun being that close to the planet to be extremely high. It'll be a healing mechanism, all right, for the planet. You know, when your body, when you get sick, the first thing you can do is you get a fever. Why? Because the body naturally, biologically, all right, turn up the heat to kill the viruses. So as the planet is evolving and this far away from the sun, then this closest to the sun, then it is naturally on the time clock schedule healing itself naturally. Like when we go to bed or lay down, or the rest to mend bones, you know, rest. A deer can get hit by a car, lay down for 2 days, jump right back up, and is back to running. Nevertheless, the healing mechanism, that was our healing time. Once again, why do we have cold weather at the healing time? But nevertheless, he said to do away with the CO2, carbon dioxide, right? That's in, what's the name? But you're not getting that naturally. It's not due to all the aerosol spray cans and the refrigerant that we use for these different type of devices. It's not. It's due to the planes. It's due to the unbeknowns of people who work in certain plants and not really know what the fuck's going on. Just because the stat goes up so far up in the air, they feel that they don't have to know exactly what, or who knows. I'm not making nothing up, but I'm not making nothing to sound like it's not. If they could tell you that it's CO2 and we need to take it away, but guess what they're taking away with? Asphalt and tree assimilation. What would that do? Wouldn't that affect the environment if you knock down the trees and put artificial trees up, like it's already doing? That's doing that too. So look at the way that they're dealing with it. They're jumping from one extreme, simply going the same damn way without no knowledge. Or do they have knowledge? Now, and why I'm saying this is because they say they're scientists. Come on now.
Deep underground at low cost. And then the lime that you produce can be used in industrial processes And in being used, it scrubs CO2 out of the air. Overall, the process is carbon negative. It removes carbon dioxide from the air. If you normally generate electricity from natural gas, you emit about 400 grams of CO2 into the air for every kilowatt hour. With this process, that figure is minus 600. At the moment, power generation is responsible for about a quarter of all carbon dioxide emissions. Hypothetically, if you replaced all power generation with this process, then you would not only eliminate all of the emissions from power generation, but you would start removing emissions from other sectors as well.
Okay,
potentially cutting 60.
Hold up, y'all. I thought he...
The oceans. This will be an enormous undertaking. You could describe it as a cathedral project.
A cathedral project. Interesting. But I'm gonna get to this real fast. I'm appreciate you for hanging around for a minute. But
CO2 levels are on the rise, but they've been way higher before, so climate, we cool here?
let's see what this one gonna say.
Hello everyone, Julian here for D-News. Antarctic CO2 levels finally caught up with the rest of the world and have an average concentration of 400 parts per million. So, for every 1 million particles in the air, 400 of them are carbon dioxide. It's the highest those levels have been in 4 million years. Now, if you're a person who watches D-News regularly, you might recognize that as a bad thing. But if you're a climate change is baloney type, you may have heard that sentence differently. If this is the highest Antarctic CO2 has been in 4 million years, then 4 million years ago, things were like how they are now, and we still turned out okay, right? Boom. Climate change busted. Actually, if you ascribe to that argument, I have even better news for you. At certain points in Earth's history, like during the Mesozoic and the time of the dinosaurs, CO2 concentrations were as high as 10 times what they are now. So why is everybody freaking out about a measly 400 parts per million? We asked University of Northridge geochemist Jen Cotton exactly that. Cotton explained that there are still a lot of things that separate our current situation from the extreme carbon dioxide levels in the past. For one thing, our concentrations are ramping up a lot faster than they ever did before. For most of Earth's history, the biggest emitter of CO2 was volcanic activity, both on land and below the ocean. But volcanic CO2 emissions are fairly slow and steady. Even during the Paleocene-Eocene thermal maximum, temperatures rose 5 to 8 centigrade over millennia, not centuries. Of course, as a geologist, Cotton described this as a really, really rapid warming event, but her sense of timing is a bit out of whack. This is why there are no geologist comedians. But over that long period of warming, organisms adapted to their changing environment, and indeed, few species went extinct during this period, which some climate change deniers use to downplay the impact of modern climate change. In fact, the current rise in temperature is happening much, much faster than it did 55 million years ago, and many organisms likely won't be able to survive. Another issue is the average global temperatures do not increase linearly with CO2. There are diminishing returns. Bumping up concentrations by 100 parts per million when it's already 3,000 is not going to cause nearly as drastic a change as if concentrations were at 300 parts per million, like they were in 1910. We're actually at the lower end of atmospheric carbon concentrations right now compared to most of Earth's history, which means that the climate is much more sensitive than it has been historically. But if it was too high in the past, won't it just come down again? Yes, climate change denier, it will. But again, on a geological timescale. CO2 is taken out of the air when it mixes with water in atmosphere and forms carbonic acid. It's why rain doesn't have a neutral pH of 7. It's typically closer to 5.5, even in the absence of any other pollutants. The carbonic acid reacts with rocks, breaking them down, turning them into soil, and being converted itself into carbonate. So yes, atmospheric CO2 has been more abundant in the past, but not for millions of years. That Paleocene-Eocene thermal maximum probably took 10,000 years to hit its peak and didn't drop to previous levels until 150,000 years later. Some people refuse to believe climate change is real because it's used to be called global warming, and changing names means scientists are lying, right? I mean, unless climate change is used now because it's the more accurate name. Trace explains all that here.
Funnily, though the internet conspiracy machine wails and cries, the survey says 63% of Americans know the climate is changing, and equal numbers on all political fronts believe humans' activities are to blame.
What do you think? Think we can turn this climate change thing around in less than 150,000 years? Let us know in the comments. Subscribe for more. I'll see you next time on D-News.
All right, Joe. You know, I'm going to stop it right here. I didn't expect to go 50 minutes or nothing like that. But it's a whole lot of things I'm going to bring to the table when I talk about it. And, yeah, and that was trying to get superconductivity information. All right. Dry ice. All right. And alcohol, 70%. If you could use 90%, I'm pretty sure you can use 50% alcohol and make liquid nitrogen. All right. It's a heck of a thing when you're studying and using the basis of electricity. What you can learn if you know what you're looking at. You know, you could take something from one type of system, grid, and place it and superimpose it on another system, biological grid, and come up with total different things. Give you an example. When you're looking at a heater, right, you know it's only a heater element, you know, a wire, a casing, a switch, and a leveler. Let's just say, well, what if I was to change the heater element into something else? Or let's give you a better example. You're looking at a car engine. Let's give you something complicated, just to you see how everything's working. What if instead of the carburetor, I use something else? Right? That was a little difficult. No, it's not, because you can use the same type of systems, putting different elements in their place, because every organ actually is interchangeable. I'll give you an example. You got a 2-barrel carburetor as well as a 4-barrel carburetor. You have high intake manifolds as well as a low intake manifold. You understand? Now, you have a lot. Matter of fact, I'm going to put this one to give you a true and deeper understanding of subliminally taking a system as simple as a calculator, or as simple as a energy amplifier, like a guitar amplifier. Take that, a guitar amplifier diagram, and say, but what is these components? What are they doing? What are they doing? What if I change this and use this? This is how you must be imagining. This is how you're going to open doors. Key maker, the key was made already. You use this to open that door. How do you get in there? You can use this to get in there. Now y'all keep it moving. I'll get back with y'all. For sure, for sure.